For the longest time, the rules for drug safety were pretty straightforward. A patient has a side effect, you just lower the dose. Simple. But today, with these incredible medicines that are actually grown from living cells, that old rulebook, it's been completely tossed out the window. We are in a brand new era, one where the most powerful cures we have are also the most unpredictable. And get this, sometimes the most dangerous side effects are actually a sign that the medicine is working. Okay, so let's break this down. On the left, that's the world we all grew up with. Think about something like an aspirin molecule. Tiny, just 21 atoms, cooked up in a lab with effects that are, for the most part, really predictable. But on the right, well, that's the new frontier. A biologic, what we call a living drug, can have more than 25,000 atoms. It isn't just mixed together, it's grown inside living cells. And its effects? Oh, they're not just about the dose anymore. They're deeply personal to each patient. And frankly, sometimes they're a total mystery. And that really brings us to the core question we're tackling today. Why is it that this huge leap forward in medical power comes with such a giant leap into the unknown? The answer, as you'll see, changes everything we thought we knew about what safe really means. To really get a handle on this new world, we first have to take a quick look back at the old one. For decades, our entire system for making sure drugs were safe was built around just one kind of medicine. The magic words here are predictable and dose-dependent. This was the bedrock of pharmacology. If a patient had a bad reaction, the playbook was simple. Lower the dose or maybe stop the drug. The thinking was always that the drug was the main variable and the patient was kind of the constant. But now, we're realizing it's the complete opposite. The patient is the variable. So now let's step into this new era. These therapies, they're not just a simple upgrade, nope. They're a totally different class of medicine and they play by a completely new set of biological rules. I want you to really focus on that phrase right there, fundamental departure. This is so key. We're not just talking about building a better mousetrap here. We've literally moved from the clean, predictable world of chemistry into the messy, complicated, and variable world of biology. So these living drugs, they come from living things, not from big chemical vats. They have these huge, complex, folded structures that can actually be slightly different from one batch to the next. And that leads to one of the most important ideas in this whole field. The manufacturing process is the product. I mean, any tiny little change in how it's made can create a different drug with totally different effects in a patient. And that brings us to our first big reason for all this unpredictability. It's not about a flaw in the drug itself. It's about the patient's own body getting the final vote. It's the immune system literally saying nope and casting a veto. This really gets to the heart of the problem. A patient's body can look at this incredibly complex, life-saving protein and see it as a foreign invader, like a virus. So it creates these things called anti-drug antibodies, or ADAs, that can literally hunt down the medicine and shut it down, making it useless or even worse, causing a really bad reaction. The therapy doesn't work, not because it was the wrong drug, but because it was for the wrong patient. And you know what? This risk isn't just random chance. It can literally be written in your DNA. This specific gene you see here, it acts like a huge flashing warning sign. If you have this gene, your immune system is way more likely to go on the attack against a whole class of common biologic drugs. Your own personal genetics can decide if a billion-dollar medicine is going to save you or do absolutely nothing. And figuring out if your body is rejecting the drug, it's not just a simple blood test. It's this whole complicated four-step investigation. First, you cast a really wide net with a screening test to catch any hint of these antibodies. Then you have to run a second, more specific test to make sure they're the real deal and not just a false alarm. After that, you measure how strong the immune response is. And finally, and this is the really critical part, you have to do another test to see if those antibodies are actually stopping the drug from doing its job. This whole process, this is the new normal. But the immune system fighting back is really only half the story. The other, and maybe even weirder source of risk comes when the therapy works perfectly, but with this overwhelming, almost devastating force. This is the incredible paradox of what we call on-target toxicity. The very thing that makes a therapy powerful enough to cure a horrible disease is the exact same thing that can make it deadly. And the poster child for this is a cancer treatment called CAR T-cell therapy. So here's what's happening inside the body. With CAR T, we take a patient's own immune cells and basically engineer them into super-powered cancer assassins.
When these cells find their cancer target and launch an all-out attack, they release a flood of inflammatory signals. A little bit of that is good. But when you have a massive, super successful attack on the cancer, you can get a cytokine storm that just overwhelms the body and leads to life-threatening problems. The cure and the poison are literally one and the same.
And the risks aren't always immediate. For some gene therapies, the danger is silent. It can pop up years, even decades later. See, to fix a broken gene, we have to insert a new working copy into the patient's DNA. But that insertion, it's not perfectly precise. And if that new gene accidentally lands in the wrong spot, it can mess up a healthy gene, like one that's supposed to stop cancer. So you end up creating a new disease while you're trying to cure the old one. This one number just drives home the massive scale of this new uncertainty. 15. The FDA requires up to 15 years of follow-up for patients who get these therapies. Just think about that. We're now in a world where getting a drug approved isn't the end of the story. It's the beginning of a decade-and-a-half-long watch party. Okay, so with all of these new unpredictable and kind of scary risks, how is the healthcare system even supposed to adapt? Well, it's having to rewrite the entire safety manual, shifting the focus from just the drug to the entire system around it. So, take CAR-T therapy again. At first, the FDA had this very strict safety program called a REMS, but then the doctors and hospitals, through an organization called FACT, basically came together and built their own, even better quality system. It became so good, so comprehensive, that the FDA eventually said, you know what, your system is better than ours, and they got rid of their own requirement. It's a huge shift from a top-down government rule to a bottom-up professional standard. And this little chart here shows what this new way of thinking looks like for a doctor in the real world. When a biologic drug stops working, you can't just up the dose anymore. You have to play detective. You measure the drug level in the blood and you test for those anti-drug antibodies. If the drug level is low and you see antibodies, boom, it's immunogenicity. The body is fighting back. The right move isn't more of the same drug, it's switching to a totally different one. It's a whole new playbook. So, what's the big takeaway here? Drug safety isn't just about the pill in the bottle anymore, not even close. It's a whole complex system. It means pharmacists are now strategic risk managers. It means we're screening people's genes ahead of time. It means complex lab tests and mandatory multi-year follow-ups, all supported by massive quality systems at hospitals to manage these powerful but unpredictable therapies. Which leaves us with this final, really challenging question. We are creating cures that honestly were just science fiction a few years ago, but they come with risks that are just as new and complex. So as we go forward, safety can't just be about avoiding harm. It has to be about mastering complexity and learning how to expertly manage the incredible risks that come with a truly curative living medicine.